I welcome you back to this tutorial on carbonyl compounds. So last time we were able to explore the type of organic reaction which is undergone by both aldehydes and ketones. And I left something behind for you to think about why aldehydes are more reactive than ketones towards nucleophilic addition reactions. Now from our previous lectures, for those of you who are watching this for the first time, we have had a series of discussions in relation to these carbonyl compounds. And in one of our discussions, we saw that, recall the following. Recall that aldehydes and the ketones have the following structures. Aldehydes basically mean compounds that have this type of structure, and ketones will basically mean compounds that have this type of structure, like that. Maybe I modify this a little bit to give it much more sense, so that it does not look a bit basic. So aldehydes will mean compounds with that structure, then ketones, they also have that type of structure. So what is ara? Ara here is hydrogen atom. For aldehydes, ara can be a hydrogen atom to come up with methanol. It can be alkyl group, or it can be aryl group. Yeah. Then here, ara or ara prime is strictly alkyl group or aryl group. We saw this some time back. So aldehydes have that representation, ketones also have that representation. Now, we are exploring how both compounds react. We are looking at how both of them react. Meaning that we are trying to see how the carbonyl functional group will behave, when it is treated with different reagents. Now, you realize that for aldehydes, look at the two structures, the one for aldehydes and the one for ketones. You realize that for the aldehydes, these ones are made up of one ara group. I have defined what ara is, what ara represents. Aldehydes are made up of one ara group. Then here ketones are made up of two ara groups. Yeah. So what does this mean? Remember, we are adding a nucleophile to these compounds. So two ara groups here, if they are alkyl groups, two ara groups, alkyl groups or aryl groups, two ara groups have two alkyl groups. Let me not use have. Two alkyl groups impose steric hindrance. Impose steric hindrance towards nucleophilic attack. But to make it a bit spicy, I'm going to say that two ara groups impose much steric hindrance. Now, this is a new term, steric hindrance. Some of you are going to be inquisitive. What do I mean by steric hindrance? Then also this side, I want to say that one R group imposes little, it imposes little or no, poses little or no steric hindrance, poses little or no steric hindrance towards the nucleophilic attack, towards nucleophilic attack. So what have I said in general? That two R groups impose much steric hindrance towards nucleophilic attack. I'm going to comment on what I mean by steric hindrance. That two groups cause much steric hindrance, then one group imposes little or no steric hindrance towards nucleophilic attack. Before I explain what I mean by steric hindrance, we need to first understand these R groups. We need to first understand these R groups. I've said the R groups can be, we can have alkyl groups or aryl groups. Alkyl groups or aryl groups. I don't know what I should start with first. Maybe I start with the steric hindrance. This is a note. However, this information was covered in introduction to organic chemistry. So I want to define steric hindrance. I want to define steric hindrance. Now, steric hindrance simply means steric hindrance. This is the hindrance or prevention, of reaction occurrence caused by presence of bulky groups. Bulky groups, e.g. alkyl groups, for example, CH3, CH3, CH2, etc. and aryl groups. Example grantyl, benzene ring. Vinyl group, sorry. So what have I said? I have said that steric hindrance, this simply means prevention. You are preventing a reaction from occurring. Prevention of reaction occurrence, and that prevention is caused by presence of bulky, groups. Yeah, groups that are heavy. So we look at how a reaction is prevented from occurring, and that prevention is caused by groups that are heavy. For example, we can have alkyl groups, and I'm going to explain why alkyl groups are heavy or why they are bulky. Alkyl groups like methyl, ethyl, among others, and the aryl group. Aryl groups. For aryl groups, it is self-explanatory. You can see that the benzene ring is a bit heavy. You can see it is made up of 6 carbon atoms. So for that case, if I call it a bulky group, you can all agree with me that indeed, since it has extended number of carbon atoms, the group is heavy. Then on top of calling benzene heavy, I also have alkyl groups. I'm also calling them bulky. So why am I calling them bulky? It's what I want to explain briefly. Alkyl groups are bulky because of the following. So alkyl groups are bulky groups because they have positive inductive effect. Alkyl groups are bulky groups because they have positive inductive effects. What do I mean they have positive inductive effect? This means they release bonding electrons. They release bonding electrons towards the atoms to which they are bonded to, i.e. CH3 has this tendency. This is what you call this is what you call positive inductive effect. Alkyl groups are heavy. Why am I calling them heavy? They are heavy because they have positive inductive effect. In simple terms, I am kind of saying that they are electron rich. They impose too much electron density towards other things. So they are heavy, and so they release bonding electrons towards atoms to which they are bonded to. Like here, I have a methyl group releasing electrons towards the carbon atom. So that's what we mean by positive inductive effect. So what have I been able to explain? It's important to know where we are coming from and where we are heading to. I have said that we have aldehydes with this structure and ketones with this structure. Aldehydes are made up of one Arab group. Ketones are made up of two Arab groups. Then I have said that these Arab groups, or two Arab groups in ketones, impose much steric hindrance towards nucleophilic attack. As in, they hinder, they prevent reaction occurrence. Why do they prevent reaction occurrence? They are bulky groups. They are bulky groups. And I'm going to explain this furthermore in detail. So they are bulky groups. These groups you are seeing here, they are heavy. So if I call them heavy, they are preventing other things from attacking the carbonyl functional group. This is what they do. Some of them are electron releasing. That is if they are alkyl groups. So these two groups here you are seeing, they release electrons towards this carbonyl part, increasing too much electron density towards it, reducing its susceptibility towards nucleophilic attack. As in, they make it electron rich. Why do they make it electron rich? Simply because they have a tendency of releasing electrons towards it. Yeah. So since they release electrons towards this carbon, they are kind of making it electron rich. Therefore, that reduces its tendency at which it picks up electrons from other things. As compared to aldehydes, which are made up of only one Arab group. The Arab group releases. It can release, however, at a little extent. That's why for aldehydes, we are saying that one Arab group imposes little or no steric hindrance. So two Arab groups impose much steric hindrance. Two Arab groups hinder the reaction greatly. Hinder the reaction greatly as compared to the case where I have one R group. Why do they hinder the reaction greatly? Simply because they are heavy. What do I mean by calling them heavy? Some of them release electrons towards the carbonyl carbon, increasing electron density towards it, reducing its rate at which it picks up electrons from the other species. So I want to write that statement here. So we want to give a clear reason as to why aldehydes are more reactive than ketones. We have said that aldehydes have this structure, so for them they have one group. Ketones have two groups which are bulky. So what are we saying here? This is the clear reason. In aldehydes, as we have seen from their structure in aldehydes, the carbonyl functional group in aldehydes is bonded to a hydrogen atom. This is what I mean. In aldehydes, the carbonyl functional group is bonded to a hydrogen atom at one end and the analkyl group at the other end. Carbonyl carbon is bonded to a hydrogen atom at one end and the analkyl group at the other end. However, for ketones, the carbonyl carbon is bonded to two alkyl groups or hydrocarbonic groups at either ends. That's what I'm saying here. The carbonyl functional group in aldehydes is bonded to a hydrogen atom at one end and a hydrocarbonic group at another end. While in ketones, the carbonyl functional group is bonded to two hydrocarbonic groups at either ends. Then I explain. If the hydrocarbonic groups are alkyl groups have positive inductive effect. And what does that mean? They have positive inductive effect. That means that they release electrons towards the carbonyl carbon, reducing its partial positivity and hence making it less susceptible towards nucleophilic attack. I have explained this. What do I mean? Let me repeat. I have said that if you have R, C, like this, these groups, if they are alkyl, they have positive inductive effect. So they push electrons towards this carbonyl functional group. Therefore, that reduces the degree of partial positivity on it. Remember, oxygen here pulls electrons, leaving a partial positive charge on carbon. Now, carbon is left with a partial positive charge, but you have groups which are pushing electrons towards it. Therefore, that should reduce the partial positivity on that carbon atom. Therefore, that should make it less susceptible towards nucleophilic attack because the degree of positivity on it has reduced. Therefore, it should be less prone towards nucleophilic attack. Moreover, additionally, also those groups are bulky. What do I mean by saying that they are bulky? They offer steric hindrance towards nucleophilic attack. As a result, ketones that have more alkyl groups are much affected by steric hindrance as compared to aldehydes with few or one alkyl group. Hence, ketones show a low rate of reactivity towards nucleophilic addition reactions as compared to aldehydes. So I want to take a quick example, a quick question. That is the general description. Want to compare, take some few examples. Question. Compare reactivity of CH3, CH2, CHO, and CH3, propanol and propanone. Compare the reactivity of the two towards the nucleophilic addition reactions. Which one is more reactive than the other? Compare reactivity of propanol and the propanone towards the nucleophilic addition reactions. So I want to say that in this case, propanol is more reactive. Propanol is more reactive than propanone. Propanol is more reactive than propanone. More reactive than propanone. Reactive than propanone. Because in propanol, the carbonyl functional group is bonded to carbonyl functional group is bonded to an ethyl group at one end, bonded to an ethyl group at one end, an ethyl group at one end, and a hydrogen atom at the other end. Whereas in propanone, the carbonyl functional group is bonded to two methyl groups at either ends. What do I mean? I've said that in propanol, look at propanol very well. This one in black. In propanol, the carbonyl functional group is bonded to an ethyl group. This ethyl group in black and a hydrogen atom, this hydrogen atom at the other end. Then while in propanone, the carbonyl functional group is bonded to two methyl groups. Is bonded to two methyl groups at either ends. So I want to say that, let me look at the time which I have here. They are 4 minutes. I hope there will be enough. So I want to say that two methyl groups offer much positive inductive effect, towards the carbon atom, that's the carbon atom, as compared to one ethyl group. Two methyl groups in propanone. Create a clear distinction. Two methyl groups in propanone offer much positive inductive effect towards the carbonyl carbon atom as compared to one ethyl group in propanol. So what do I mean? They release electrons towards the carbonyl, carbon atom, decreasing its degree, decreasing its degree of positivity, and hence making it less susceptible, towards nucleophilic attack. I am running out of time. They release electrons towards the carbonyl carbon atom, decreasing its degree of positivity and hence making it less susceptible towards nucleophilic attack. Additionally, the two methyl groups offer much steric hindrance, towards nucleophilic attack as compared to one ethyl group, in propanol, which offers